Good morning, grade 9 students. Welcome to our geometry class. Our lesson for today is Properties of Parallelograms, textbook pages 359 until 366. Our objectives: to use relationships among sides and angles of parallelograms, and to use relationships among diagonals of parallelograms. Please take note of the following. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So this figure is a parallelogram since opposite sides are parallel. In a quadrilateral, opposite sides do not share a vertex, and opposite angles do not share a side. In this case, we are here given parallelogram ABCD. Opposite sides are AB and CD. Also, BC is the opposite side of AD. And angle A and angle C are opposite angles. Angle B and angle D are also opposite angles. You can abbreviate parallelogram with a symbol like a parallelogram, and if it is plural, just put S inside that symbol. So let us first watch a video about parallelograms.
Let's define a parallelogram. To do this, let's take the example of a parallelogram written on the board and see if we can figure out what makes it a parallelogram. Well, here we have a figure that has four sides. A four-sided figure is a quadrilateral. So that means that a parallelogram is a type of quadrilateral. Now let's take a close look at the sides of this parallelogram. Here we have this side and this side. It looks like those sides are parallel to one another. And in fact, if we take each one of these sides and extend them out in either direction, just like this, we actually get two parallel lines. These lines will go on and on forever without ever intersecting. So these opposite sides are parallel to one another. But what about the other sides? This side right here and this side right here. Well, if we take those sides and extend them out in either direction, just like this, we actually get another set of parallel lines. So that means in this figure, opposite sides are parallel. Now take a closer look at the opposite sides. Again, we said that this side and this side were parallel to one another. But if we look closely, we can see that they're also the same length. Since these sides are the same length, we say that they're congruent. So side AD is congruent to side BC. This symbol means congruent to. Here, we're indicating that these two sides are the same length. And if we want to show that in our figure, we can do this. Draw a mark on each one of the sides. That mark indicates that those two sides are the same length. And if we look at our other set of opposite sides, we can see that they're not only parallel, but they're congruent as well. Side AB is congruent to, or the same length as side DC. And to mark that on our figure, we can put these two marks on each one of the sides. These marks indicate that these two sides are the same length. So, in this figure, the opposite sides are parallel and congruent. Well, in a four-sided figure, if opposite sides are parallel and congruent, that means that opposite angles are congruent too. So, angle A and angle C are opposite angles and they're congruent to one another. That means that they're the same length. That also means that angle D and angle B are also congruent to one another, since they are opposite angles as well. So now let's define a parallelogram. A parallelogram is a type of quadrilateral where the opposite sides are parallel and congruent. So, if we have a four-sided figure that has two pairs of parallel and congruent sides, we have a parallelogram. Now there are a few other quadrilaterals that can be qualified as parallelograms. So let's take a look at a few other four-sided figures and see if they classify as parallelograms. First, let's take a look at a rectangle. A rectangle is a four-sided figure. In this four-sided figure, all four interior angles are right angles. That means each interior angle measures 90 degrees, which we indicate by this little box. Now, is a rectangle called a parallelogram as well? Well, does it meet the requirements to be a parallelogram? To be a parallelogram, the opposite sides must be parallel and congruent. If we look at these opposite sides, we can see that they are parallel and congruent. And if we look at these opposite sides, we can see that they are parallel and congruent as well. Since a rectangle has two pairs of parallel and congruent sides, that means that yes, a rectangle can qualify as a parallelogram. But not all parallelograms are rectangles. Notice, this parallelogram written on the board is not a rectangle. It does not have four interior right angles. So, all rectangles can be called parallelograms, but not all parallelograms are called rectangles. Now let's take a look at a rhombus. A rhombus is another four-sided figure. In this four-sided figure, all four sides are congruent. So, all sides are the same length. Since all sides are the same length, we know that opposite sides are congruent. And if we take a close look, we can see that the opposite sides are also parallel. So that means that yes, a rhombus can be classified as a parallelogram. Now, just like we had with the rectangle, every rhombus is a parallelogram, but not every parallelogram is a rhombus. Here, this parallelogram is not considered a rhombus. Not all four sides are the same length, the requirement to be a rhombus. Now let's take a look at a square. A square is a four-sided figure where all four interior angles are right angles and all four sides are congruent. Again, because all four sides are the same length, we know that opposite sides are congruent. And if we look, we can see that those opposite sides are also parallel. Since we have two pairs of opposite sides that are parallel and congruent, that means that yes, a square can be classified as a parallelogram. And again, not every parallelogram is necessarily a square. Finally, let's take a look at a trapezoid. A trapezoid is a four-sided figure with one pair of parallel sides. Here we have a pair of parallel sides, right like this. But look at the other pair of opposite sides, here and here. Those sides are not parallel to one another. That is one of the requirements to be a parallelogram. Both pairs of opposite sides needs to be parallel. And in a trapezoid, we only have one pair of parallel sides. That means that no, a trapezoid cannot be classified as a parallelogram. And now we know more about parallelograms. If we have a four-sided figure where the opposite sides are parallel and congruent, then we have a parallelogram. And a rectangle, a rhombus, and a square are three different types of specific parallelograms.
Okay, so let's have here theorem 6-3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So here, if ABC is a parallelogram, therefore BA is congruent to CD, and also BC is congruent to AD. It means to say that in a parallelogram, opposite sides are congruent. Angles of a polygon that share a side are consecutive angles. So here, in this case, we have here angle A and angle B are consecutive angles since they share side AB. So what can you say about the measurement of consecutive angles? So we have here theorem 6-4. which states that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, meaning to say angle A and angle B equals 180. Also, angle B and angle C equals 180. Angle C and angle D is 180, and angle D and angle A equals 180. So again, consecutive angles are congruent, are equal to 180. So let's discuss problem 1. Okay, so let's discuss problem 1 on page 360.
In this problem, you will use consecutive angles. What is the degree measure of angle P in parallelogram PQRS? Your choices are A, 26, B, 64, C, 116, and D, 126.
Okay, so here we know that consecutive angles in a parallelogram are supplementary. So since this is the question, we are asked for the measure of angle P. So this is asked. So angle P is supplementary to the given, which is angle S. And angle S measures 64 degrees. So here, consecutive angles in a parallelogram are supplementary. So meaning angle P and angle S are all equal to 180. So substitute for the value of angle S. So angle P is equal to 64 equals 180. So to solve for angle P, we'll just subtract 180 minus 64 equals 116. So meaning the measure of angle P is 160. So it is choice C. Okay, so let's answer got 1. Suppose you adjust the lamp so that measure of angle S is equal to 86. What is the measure of angle R in parallelogram PQRS? So we have here the given is the measure of angle S is 86. And we need to find the measure of angle R. So the solution for that is, since angle S and angle R are consecutive angles, therefore we can say that the measure of angle R plus the measure of angle S is equal to 180 because consecutive angles are supplementary. So the measure of angle R plus the measure of angle S, which is 86, is equal to 180. Solve for R. 180 minus 86 is equal to 94. So meaning angle R is equal to 94 degrees. Okay, so let's have theorem 6.6-5. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So meaning to say, angle A is congruent to angle C, and angle B is congruent to angle D. So this is the meaning of theorem 6-5.
In this problem, you will use properties of parallelograms in a proof. You are given parallelogram A, B, C, D. Prove that angle A is congruent to angle C, and angle B is congruent to angle D. Start with the given information. Quadrilateral A, B, C, D is a parallelogram. Remember that consecutive angles of a polygon share a side. So angle A and angle B are consecutive angles by the definition of consecutive angles. Angle B and angle C are also consecutive angles by the definition of consecutive angles. And angle C and angle D are consecutive angles by that same definition. Angle A and angle B are supplementary, because consecutive angles of a parallelogram are supplementary. Angle B and angle C are also supplementary because consecutive angles of a parallelogram are supplementary. And angle C and angle D are supplementary for that same reason. Both angle A and angle C are supplementary to angle B. So angle A is congruent to angle C since supplements of the same angle are congruent. Both angle B and angle D are supplementary to angle C. So angle B is congruent to angle D since supplements of the same angle are congruent. You have proven that angle A is congruent to angle C and angle B is congruent to angle D. Why is the flow proof useful here? A flow proof allows you to see how the pairing of two statements leads to a conclusion.
Okay, let's answer got it too. Use the diagram at the right, given parallelogram ABCD and AK is congruent to MK. So we need to prove that angle BCD is congruent to angle CMD. Okay, now refer to our figure. So this is a parallelogram ABCD. You know that parallelogram has its properties. Okay, and then AK, side AK is congruent to side MK. Okay, now here, we will always start our proof with the given. So here, we have here parallelogram ABCD. So that is our first given. Parallelogram ABCD, and the reason is given. And AK is congruent to MK. That is the second given. Now, what properties can we write since ABCD is a parallelogram? So therefore, we can say that angle A is congruent to angle BCD. Why? Because opposite angles of a parallelogram are congruent. That's the reason for that. Okay, so we already have here a pair of congruent angles. And you need to plan, is there any angle from this that can be paired to this angle so that they can be proven to be congruent? Okay, so that will be the question that you need to think. Now here, let's go back to our second given. It says that AK is congruent to MK, this side. Now, if two sides of a triangle are congruent, therefore we can say that that triangle is isosceles. Why? Because from the definition of isosceles triangles we're in, if one side is congruent to another side, therefore the triangle is congruent. Now, based on the isosceles triangle theorem, we can say that since this side is congruent to this side, therefore the opposite angles are also congruent, meaning this angle here, A, is congruent to angle M. Why? Because of the angles or the sides opposite them are also congruent. So therefore, they are also congruent. That is the meaning of isosceles triangle theorem, that states that if this side is congruent to this side, therefore the angles opposite them are also congruent. So this angle M and angle A are congruent. Now here, from these two statements, two pairs of angles that are congruent, and they have a common angle between them, which is angle A. So since angle A is congruent to these two angles, therefore this angle is also congruent to this angle. Therefore, as a final conclusion, we can say that angle BCD is congruent to angle CMD. So that is the proof. So what we are going to write as a reason is that is transitive property of equality. Like, for example, as I'm always saying, if A is equal to B, then B is equal to C, therefore A is equal to C. That is transitive property of congruence. So we already went to our final statement wherein this one will be the one written on the statement to be proven. So that's the end of our proof. Okay, so this is theorem 6-6. If a quadrilateral is a parallelogram, then its diagonals bisect each other. What is the meaning of diagonals first? The diagonals is a segment formed from opposite angles of a parallelogram. So in this case, the diagonals in these figures are AC and BD. So what can you say about these diagonals? So here, these diagonals bisect each other, meaning the point where they intersect create congruent segments. So look at diagonal AC. The point where they intersect is at point E. Therefore, we can say that AE is congruent to EC. And BE is also congruent to ED.
In this problem, you will use algebra to find the lengths in a parallelogram. Solve a system of linear equations to find the values of x and y in parallelogram KLMN. What are the lengths of segment KM and segment LN? The diagonals of a parallelogram bisect each other. So segment KP is congruent to segment MP. And segment LP is congruent to segment NP. Set up a system of linear equations by substituting the algebraic expressions for each segment length. Use the quantity y plus 10 for the length of segment KP. Use the quantity 2 times x minus 8 for the length of segment MP. Substitute the quantity y plus 2 for x in equation 1, then solve for y. Use the distributive property. Then simplify. Isolate the variable to solve. So y equals 14. Now substitute 14 for y in equation 2, then solve for x. X equals 16. Use the values of x and y to find the lengths of segments KM and LN. Substitute y plus 10 for the length of segment KP. Substitute 14 for y. So the length of segment KM is 48. Substitute x for the length of segment LP. Substitute 16 for x. And the length of segment LN is 32.
Let's answer got it 3. So here we have find the values of x and y in parallelogram PQRS at the right. And what are PR and SQ? So this is the parallelogram PQRS with the length of the diagonals as given here. So here we have the value of x and y. We know that these diagonals were bisected with each other. So meaning 3y minus 7 is equal to 2x because these segments of these diagonals are congruent. And then ST is congruent to TQ. So x plus 1 is equal to y. So we are going, since we have two variables here, x and y, we are going to use the system of linear equations to solve for the values of x and y. So in this case, since the value of y is written as x plus 1, it's easy to use the process of substitution. So 3, using our first equation, we are going to substitute for the value of y. So this is 3y. So instead of writing 3y, since y is equal to x plus 1, so we are going to write it in place of y. So this is now y is equal to x plus 1. Minus 7 is equal to 2x. Meaning equation 2 was being substituted to equation 1. So multiply 3 times x is 3x plus 3 minus 7 is equal to 2x. Combine like terms. So this is 3x minus 4 equals 2x. Transpose 2x to the other side. So this will be 3x minus 2x will be x. So x is equal to 4. Now we already have the value of x. Now we can easily solve for the value of y using equation 2 by just substituting the value of our x. So using equation 2, which is y is equal to x plus 1. So here, what is the value of y? Since our x is 4. So 4 plus 1. So our y is 5. So we have now the values of x and y. X is 4 and y is 5. Now the next question, what are PR? Meaning, what is the length of PR? So let's just say that this is PR. PT plus DR is all equal to segment PR. So here, segment PR is equal to, this is 3y minus 7 plus 2x. Now substitute for our values of y and x. So this will be 3, our y is 5, minus 7 plus 2, and the value of our x is 4. So this will be 15 minus 7 plus 8. So this will be 15 minus 7 is equal to 8 plus 8 is equal to 16, meaning PR is 16. Okay, now what about SQ? So we have here the diagonal SQ is equal to, this is SQ, all of this till here. So this is x plus 1 plus y. So our x again is 4 plus 1 plus the value of our y, which is 5. So meaning to say our SQ is 10. So this is the solution for got it 3. Let's have theorem 6-7. If 3 or more than 3 parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So in this case, line AB is parallel to line CD and is parallel to line EF. Therefore, AC is congruent to EC. So what about the segments that were cut from the another transversal, which is this line BF? So also, BD is congruent to DF.
In this problem, you will use parallel lines and transversals to determine segment lengths. In the figure, line AE is parallel to line BF, which is parallel to line CG, which is parallel to line DH. Also, the length of segment AB equals the length of segment BC, which equals the length of segment CD, which equals 2. And finally, the length of segment EF equals 2 and 25/100ths. What is the length of segment EH? You know that line AE is parallel to line BF, which is parallel to line CG, which is parallel to line DH. You also know that the length of segment AB is equal to the length of segment BC, which is equal to the length of segment CD, which is 2. Finally, you know that the length of segment EF is 2 and 25/100ths. What information do you need? You know the length of segment EF. To find the length of segment EH, you need the lengths of segment FG and segment GH. Since parallel lines divide segment AD into equal parts, they also divide segment EH into equal parts. Now use the segment addition postulate. Since all 3 segments are equal, substitute the length of segment EF for the length of each segment. Substitute 2 and 25/100ths for the length of segment EF. Simplify. So the total length of segment EH is 6 and 75/100ths.
Okay, so here's the solution for got it 4. In the figure, line AA is parallel to line BF, parallel to line CG, parallel to line DH, wherein EF is equal to FG is equal to GH, which is equal to 6, and AD equals 15. What is the measure of CD, or what is the length of segment CD? So these lines are parallel to each other, and these lines cuts this segment into equal parts. So here it is given that EF is equal to 6. Then all of this are all equal to 6. Now here, since this transversal was cut into equal segments, therefore this transversal was also divided into congruent segments. Then it is given that AD is 15. meaning segment A until D is 15, meaning the whole segment here is 15. Question, what is the length of CD, meaning only this part? So, since this transversal was divided into congruent segments, therefore we know that this transversal were also divided into congruent segments. So what is the measurement of AB? It will be equal to the measurement of BC, and it is also equal to the measurement of CD. So if the whole segment is 15, so the solution will be 15. The total or the whole segment will just be divided by how many parts were there? 1, 2, 3. Just 3 parts. So it is equal to 5. So meaning to say, AB is equal to 5, BC is equal to 5, and CD is equal to 5. Since the total segment here will be the total length of the segment is 15. So here, the final answer, segment CD is equal to 5. So this is our lesson for this week. If you have any questions, just don't forget to send us message. Thank you for watching.